Here's an example of an application problem that can be solved using the law of cosines. If this person wants to determine the distance across this lake from the given information, we can do so using the law of cosines. So looking at this triangle here, we want to determine the length of side x. And often the law of cosines is expressed three different ways, but the most important thing to recognize is the relationship among the three sides and the given angle. Remember that side A is always opposite angle A. And it's also true that sides B and C form angle A. So looking at our triangle, we should call this angle A because it's the angle that we know the measure of, which means that the opposite side must be in the position of A in this formula. Notice that these two sides form the known angle, so we can label these two sides B and C. And again, if we switch B and C, it doesn't really matter. Again, it's a relationship among these three sides and the known angle that are important to apply the law of cosines. So if we want to determine the length of side x, we would have x squared by itself on the left side of this equation. So we'd have x squared equals 2.5 squared plus 1.8 squared minus 2 times 2.5 times 1.8 times the cosine of 36 degrees. I'm going to go ahead and evaluate this with the help of the calculator. So we have 2.5 squared, and we have 1.8 squared, and then we're going to subtract this product here, so we'll have 2 times 2.5 times 1.8 times cosine 36 degrees. Let's just make sure that we're in degree mode, and we are. So we're going to have 6.25 plus 3.24 minus approximately 7.28. Let's go ahead and write that down. So we're going to have x squared equals 6.25 plus 3.24 minus approximately 7.28. Now let's go ahead and determine this sum and difference. So again, we'll have 6.25 plus 3.24 minus 7.28. So x squared is approximately 2.21. And now we can square root both sides of the equation. We know it's a distance, so we only have to be worried about the positive square root. So we have x is approximately equal to the square root of 2.21. So the distance across the lake is approximately 1.5 kilometers. I hope you found this example helpful.